express our sincere thanks for joining today's session on Smart Factory with Connected Operations on a case study. We express our sincere thanks to Mr. Hemant Patil, who is the Smart Factory Strategist and Industry 4.0 Evangelist, for accepting our invitation to address our members over this session. Thank you very much, sir. The session is organized under the aegis of Industry 4.0 Expert Committee, chaired by Mr. N. Chandramouli, who is also the keynote speaker for today's session. The committee is co-chaired by Mr. Jagannath, who is the business head of M2 Next, a BFW subsidiary. Thank you very much once again to all of you for joining this session. I now hand over the platform to the chairman, Mr. Chandramouli. Over to you, sir.
Thank you, Rupa. Am I audible, Hemant? Am I audible, Rupa?
Yes, sir. Clear, sir.
Yes, clear.
Good. I welcome Mr. Hemant Patil to the first session of his on the Bangalore Chamber platform. Bangalore Chamber, Hemant, is a chamber with 800 members plus. I think it must have crossed 900 now, of which around 50-60% is manufacturing. Other 30-40% is service sector, education sector. Is my slide visible, Hemant?
Yeah.
Okay. Without much ado, I will make some introductory remarks. I welcome all the participants. I think around 30 participants already joined. Normally, by the time I finish my introductory session, we would have crossed 100. Let us, being a Saturday, I'm sure there must be good attendance today. Let me now move on to my slides. Okay, today's topic is a very, very contemporary topic, smart factory with connected operations. The word smart, I think, is very, very familiar to all of us. Smartphone, smart city, smart cars, and so on and so forth. Factory, needless to mention. Anywhere a raw material is converted into finished products is a factory. And connected operations is a key point of today's talk by Mr. Hemant Patil. I don't want to take away his initiative on this. And Hemant Patil is really an evangelist. Exp Com is a smart factory consultant. Until recently, he was with Tata Technologies as a very senior director. And Hemant, are you able to see my second slide?
Sure, sir.
Is the photograph looking like you?
Yeah.
Thank you. And breaking the silos, breaking the compartments, silos, with a connected smart factory is the theme of the day, and it benefits in achieving two goals. The number one goal is operational excellence, which means customer satisfaction through quality, delivery, cost, flexibility. The four weapons of operational excellence, about which I have spoken many times in this forum: quality, delivery, cost, and flexibility. The fourth weapon is flexibility. And Hemant has brought in very explicitly the fourth weapon in the form of agility in the manufacturing operations. And therefore, I think it's a very complete kind of a theme today. A brief background of Hemant, I don't want to read the whole thing. He has had a long career with GE and Tata Technologies. And he is also an advisory board member in the University of Pune and in IIT Ranchi. He is a computer engineer from Pune University. And he did his graduation from Pune Institute of Computer Technology in 1991. Very young man compared to me. He is a subject matter expert and an evangelist of Industry 4.0 solutions. He is a practicing manager, not a theoretician like me. With 30 years in the deployment in plant, floor, and IT systems, integrating IT and OT, IT-OT integration. OT being the operations technology and IT being the information technology and internet technology, ICT, internet and communication technologies, in multiple industries: auto industry, aerospace, steel, refineries, process industry, so on and so forth. And he has been a catalyst in the organization where he worked for. He also had a stint as a consultant in between. Then he joined back Tata Technologies. Again, he has left, become a consultant. Once you are a consultant, you never like to go back to full-time job. Yeah, Hemant?
That's true.
And he has done projects across the world. I hope he will give us a lot of wisdom or insights into the global case studies. So before I hand over my mic to Mr. Hemant, I will just quickly, always a refresher is useful. And Hemant requested me to do a small refresher of the theme as well as the overarching subject. I am happy to inform all of you that this is the first of a series of webinars in 2022. Of course, last month, we had one very good one on service sector, but on the manufacturing sector, which is the primary sector for smart manufacturing, we have the series of webinars starting today. There will be 2 such per month. And later on, I think Rupa will inform you through a circular. We're just finalizing the complete schedule up to June. And there'll be at least 10 speakers over 5 months, so 2 each going up to June. And for 1.0, 2.0, 3.0, you are very familiar. Very quick way to remember them: mechanical revolution, electrical revolution, computer revolution, and internet-based revolution. Yeah, that is a very quick way of understanding. And in the latest revolution, we are talking about connected, as Hemant is going to emphasize. Self-optimized, that means autonomous. Equipments can talk to themselves without depending on human beings to intervene. And finally, real time, that means data is flowing on a minute-to-minute, second-to-second basis. Not the conventional ERP systems, which were very famous in the industry 3.0 area, that period era. And whereas 4.0, has moved away from the conventional ERP system kind of MIS to real-time MIS through real-time dynamic dashboards. The key drivers are very, very important to understand. I will touch upon them a little more in the subsequent slides. Very important, what is being connected here? I'm sure Hemant is going to illustrate this point. I visited Siemens in Kalwa in Bombay. All these illustrations are Indian, so nobody need to worry that Industry 4.0 is for the developed world and not for the developing country called India. Siemens Kalwa, starting with design, planning, production engineering, production execution, and after-sales service. The complete value chain, as you call it, or the product life cycle, PLM, on the one hand, to improve the speed of response, to improve flexibility, to improve quality, to improve efficiency and cost. Everywhere you talk about the QDC and flexibility. The fourth dimension, flexibility, is coming here. And through a platform called MindSphere, they addressed it through many software. There are at least 16 software solutions. Yeah, one day we will invite Mr. Ayappan Ramurthy to talk about it. But I just took it as an illustration. I visited them in Bombay long back. And the very, very important point on this thing is how do we look at the value chain? The value chain. Inbound logistics, operations, outbound logistics, sales and marketing, after-sales service, support activities such as infrastructure, human resources management, technological development, procurement, purchasing, supply chain. All the functions, whether it is a core function or whether it is support function, or can be connected, primary activities and support activities in the entire value chain can be connected. And if you can remember, this value chain diagram is for one company. Imagine in a chain of companies, like typically in automobile industry, we have OEM, tier 1, tier 2, tier 3, tier 4, and every one of the companies supplying the components to the OEM are part of a value chain. And within the company, also there is a value chain. And this value chain contains primary activities and secondary activities. If you go on linking all the value chains, and I think Hemant is going to touch upon how powerful it is going to be in the era of digital manufacturing, when all the entities in the ecosystem is connected with each other, not only the equipments within a factory, but equipments and devices across the value chain. And on that note, recap on the various technologies of Industry 4.0. The backbone of all the technologies is Industrial Internet of Things, IIoT. And the other one is integration and digitalization and system integration. On the system integration, I will touch upon briefly. I think Hemant's session today is all about system integration and connectivity of the various technologies. On the one hand, connectivity of the value chain, connectivity of the entire product life cycle, and on the other hand, connectivity of all the technologies is also very, very important. When all the technologies are integrated and all the equipments integrated, we can get the maximum benefit out of the Industry 4.0 technologies. I want to only give a 30 seconds on the concept. The 5 drivers and impacts of Industry 4.0. I want, ladies and gentlemen, to really pay attention to this particular slide. This is my core slide for the day, and I will repeat this in every one of my webinars coming during 2022. The number one I already talked about, impacting entire value chain. Industry 4.0, as we are talking last 5 to 6 years all over the world, is impacting the entire value chain through multiple technologies. Already I showed you technology driven solutions. The technologies are not at all so important as compared to the solutions. And product life cycle management, which is nothing but design to after sale service. The one I showed you on the Siemens picture. Design to after sale service by enabling real-time feedback, dynamic real-time feedback, so that when you have a problem in the after sale service, you can improve the situation in the manufacturing, you can improve the situation in the supply chain, you can improve the situation in the vendor base, you can improve the situation even on design and development. This is the one major impact of Industry 4.0. Therefore, individual point solutions are of no benefit. One needs to connect the entire enterprise, or if possible, entire ecosystem to which the enterprise belongs to. The second major impact is on the business KPIs and customer value in various areas, including quality, delivery, efficiency, safety, and above all, flexibility, which I mentioned to you. And one of our great speakers is coming in the month of April to talk about how customer value is benefited through Industry 4.0 and how the return on investment can be realized through these kind of concepts. And of course, all of them are driven in the last 10 years through mass customization and flexible manufacturing requirements, which is further accentuated and aggravated by COVID pandemic and other reasons. The disruptions, as we talk about in the last 20 years, the disruptions have become a permanent feature. And high level of traceability and tracking in the entire value chain is required when you are having a mass customization. That means variety of parts in every business, and also flexible manufacturing to feed the customer, the particular customer, with a personalized feature of any product, be it a fast moving consumer goods or even for that matter, a machine tool or an aircraft or an automobile. And of course, all of them are leading towards enhancing the benefits of lean practices through proactive quality management, through proactive response time improvement, through proactive asset utilization. On about asset utilization, one of our colleagues is going to speak very soon, I think in the month of March, on how to maximize asset utilization in the process industry. Yeah, Mr. N.P. Sundar is going to talk about that. Mr. Gautam Datta is going to talk about the business value. And please watch this space. There are many good speakers coming up this year. And last but not the least is combined digitalization and automation in the industry, is extremely important. Many people think Industry 4.0 is all about digitalization. But my good friend Jagannath, my co-chair, is expert in automation. He is going to talk somewhere in March, end or April, about how intelligent automation can be deployed for mass customization. And all these are leading to, again, operational excellence, which further leads to business excellence. So, in my opinion, these are the 5 drivers and impacts of Industry 4.0. And this particular slide I made exclusively for Bangalore Chamber of Industry and Commerce. Right? Particular point from my side, I think Hemant is going to talk about, not to steal the thunder from him. The connectivity is both in the horizontal direction and in the vertical direction. What I talk about, the horizontal integration and vertical integration, about which we also talked about in another session when we discussed smart machine tools. Let me give an illustration of what I'm talking about, the horizontal integration. You have a machine tool, you have a robo, you have a AGV, etc., cutting tools, and even our workpieces and the fixtures. And then we have a digital twin, which is nothing but the true mirror image of the physical system. The mirror image of the physical system is called the digital twin. That means there will be a mirror image of the machine tool, there will be a mirror image of the robo, mirror image of the AGV, mirror image of the workpiece, mirror image of the cutting tool, and so on and so forth. When all these cyber twins combine together, we call it cyberspace. So there is a physical space, there is a cyberspace. When you combine the two, you get cyber physical systems, CPS. Many times we get a lot of jargons, but this picture is beautiful picture. I picked it up from a Chinese website. Can you imagine? Chinese website. And the service cloud is nothing but all the data analytics, either through machine tool providers or cutting tool providers, third-party providers, and all the equipment providers, as well as the ERP system and other people. They bring in together the MIS and the data analytics coming from both the physical systems and the cyber system through sensors, etc., etc. Yeah, and these are explained in this. Not to go to this detail, I will send this thing. And I think we have a quick video. Let me see if the video works. This is a very interesting case study. Are you all able to see the video, the picture? Hemant?
Yes, sir.
Rupa? Yes. Now I will switch on. I will see how to switch on the video. For which I think I need to. Are you all able to hear the voice? Noise?
Yes.
Great. This is a Atlas Coppo
Assembly
video.
lines today feature
Another
multiple
one from
parallel
Siemens. After
activities,
that, I hand over the
automation
mic to
and
Mr. Hemant Patel.
digitalization. This means new challenges in the whole quality process. Atlas Copco's QA Platform 4.0 is the answer to combine new manufacturing techniques with higher quality to achieve real smart connected solutions. Data and statistics from all data collectors are merged and analyzed with QA Supervisor software to schedule routes and monitor the complete quality process. The personalized dashboard of QA Supervisor software provides a clear and immediate overview of the quality process, allowing the quality manager to easily monitor and assign tasks to the operators. The operator receives his tasks online on his device, enabling direct communication with the quality manager. QA Platform 4.0 can standardize and digitalize your process and also provide operator guidance during the tests. A mobile device enables the flexibility of the operator. Alternatively, a smaller ST Palm can be used. Many tests in a factory are performed visually, such as optical inspections and OK, not OK. The tool check operations can be performed with a high level of flexibility. The ST bench can replicate the exact behavior of the real joints in the production line, providing reliable acceptance criteria for the validation. The ST pad is easily docked on an ST bench for immediate testing. The ST bench guides the operator, highlighting the brake to be used. The ST bench is equipped with all the accessories necessary for test execution. Starting the test is simple and execution is fast, increasing productivity for machine capability tests. The joint check procedures are displayed on the ST pad. Clear instructions show how to perform the tasks. The combination of ST pad and ST wrench, with its patented algorithm for real-time residual torque detection, provides the most comprehensive solution for joint checks. The QA Platform 4.0 also includes non-torque related inspections. Just one example is the dimensional check that can be scheduled and performed automatically. The interface guides the operator and the data is stored on the ST pad, eliminating human error and sent to the QA supervisor. If fixtures have to be tested during production, a simple way is to use an IRC Connect, a new way of making your transducers smart and wirelessly communicating even in offline mode. With storage capacity of up to 5,000 measurements and the possibility to operate remotely in dangerous areas. The operator is guided through the scheduled test intervals. If defects appear or condition has to be documented, the integrated camera can be used effectively to record images in the database. All quality-related inspections have been performed using the QA 4.0 platform, ensuring the highest quality of the assembled product. The quality manager can deeply analyze all the tests performed and monitor the history of every single detail of the process. Final check is okay, and another car of the highest quality is released to delight its customer on the road. This is quality assurance in a new light. The QA Platform 4.0 from Atlas Copco can help you to fully safeguard the quality of all your products.
Well, I hope you all enjoyed that. There is another interesting one which gives you a very good picture about the importance of connectivity. Is audio clear now?
Our world is becoming ever more connected.
Yes, sir.
Billions of intelligent devices and machines generate massive data, bridging real and virtual worlds. Complex data now play a crucial role in the way we move, live, and work, the way we plan and create products and services. Turning the vast amounts of data collected every day into value is a key success factor for companies, economies, and entire societies. We have the domain know-how to transform the big data generated by our systems and products into rich information that enables smart choices. Our data-driven services monitor power plants to guarantee reliable energy supply. Our software and IT solutions teach wind powers how to produce more, and our building management systems teach buildings how to consume less energy. We enable our customers to intelligently automate processes across the entire life cycle of their products. And by simulating real-world objects by means of digital twins, we help them optimize their manufacturing processes. Our intelligent traffic management systems help moving people and goods faster, safer, and with less CO2 emissions. And we develop sophisticated medical imaging systems that help doctors make better decisions faster. We seize the data opportunity to create real value.
Okay. I hope all of you enjoyed those last two videos. One was dedicated to the connected operations to improve quality management, and the other one talked about connecting the entire ecosystem, including connecting cities, if not just the factories. Okay, I think without much ado, let me hand over the mic to Mr. Hemant Patil. And needless to mention, all of you who have joined and those who want to join, please feel free to text your doubts, clarifications, appreciations, comments, whatever you want to put on the text box, which we will take it up at the end of Hemant's session, which will be roughly 1 hour plus. Yeah, around 12:30, 12:40, 12:45, we can have a Q&A for 15-20 minutes, and Mr. Hemant will take up most of the questions. Wherever required, I will chip in. And I thank all of you to join today on the Saturday morning. And Mr. Hemant, all set?
Yeah, thank you, sir. Thank
Thank
you.
you, Hemant. Thank you.
Thank you for a nice and crisp introduction and setting up the platform nicely for the forthcoming session on connected operations with a smart factory. I appreciate, and at the same time, I appreciate and thank you for providing this platform, making it available for me to present my case study or my thought process to the larger audience of BCIC. And I welcome all the audience on this session. So just to begin with, I'll share my screen.
Will you be coming on the video also, Hemant?
Okay, at the beginning, I may come on the video, but
Because
if
it
it
will help to, when we put on the YouTube, it look very nice.
right. So
As
I
long
have
as
put
you have a
on the,
bandwidth, if the bandwidth is good, you can be on the video. No problem.
I'm already on my video. I hope it is not
Yes,
hampering the
we
bandwidth.
can we
And
can see the screen, we can see the video absolutely top class. Thank you, Hemant.
great, great. Thank you very much. So this is the topic basically today, the connected smart factory operations for operational excellence, right? And this is the larger agenda or a detailed agenda where we'll be seeing a case study. So when Mr. Molly approached me and wanted me to present a session on smart factory, so instead of just going through a monotonous theoretical lecture or maybe a thought leadership kind of lecture, I thought of making it more practical so that you understand what really happens, how it helps on the grounds in the real world. So I decided to make it based on a case study, which is not a very complicated one, but it's enough to explain the features of the connected factory and how simply it can be achieved, and the siloed functions, which is the major bottleneck in the today's manufacturing world, how those can be overcome to achieve real benefits and operational excellence. So we'll begin with the case study problem statement, why this project was taken up or how the solution came up. What is the operational excellence 4.0? Now, this operational excellence, as Mr. Molly also said, is everlasting thing, right? It's a perpetual thing. Only thing with the technologies which are evolving, there are newer avenues and optimizations which are helping to achieve this goal or reduce or take the higher targets in terms of saving the cost or doing better quality, right? So followed by that, we'll be just going about how what was the solution strategy in giving this solution for the customer, and what was the approach taken. So this is a high level thing where we'll discuss about the strategy and the approach, right? The principles which were referenced. Then there is a smart factory reference framework. So there is a standard smart factory model which I have prepared, and we'll take a reference to that model. And same was referenced for devising the solution for this customer as well, which is an industrial heavy machinery manufacturer or industrial equipment manufacturer customer. So we'll see what are the features out of this smart factory global model or future state model are referenced here. And most importantly, operational excellence targets, which were taken as the improvement targets through this solution for the customer. Then sixth topic will be around the construct of the solution. So what are the components or architecture of the complete smart factory solution? And there were some, again, reference architectures of Industry 4. So some pieces, bits and pieces are collected together to devise the solution. So we'll talk about those things in detail. Then there are implementation best practice. So other than the solution, there is an important point on digital transformation is about following the better practices or best practices while implementing these solutions. So traditional way of big bang and other things are no more working or no more giving the results what are expected because of their very nature of being rigid. Everything is firm up at the beginning, and then we struggle to make the change management. So it goes into litigation, mitigation, discussions, conflicts with the customer because it is associated cost. So there is an agile approach. At the same time, there are some things like template based approach. So we'll discuss on the template based approach and the rationale behind choosing this process or this practice. And then finally, we'll see some use cases and the outcome, the result of the solution. So use cases meaning what are the functionalities or the features which are deployed in this solution for the customer's requirement to solve the problems. And there will be, if time permits, some sample screens and dashboards are there. So those are just static things, so does not matter much. But this is how we'll go. So first, I would request all of you to type in your name, your designation, and name of your company in the chat box. This you can take your time and keep on doing it so that I can know what is the kind of audience I am having, and then I can tune in my discussions or my thought process accordingly. So let us start with the executive summary of this case study, right? So this is, as said, is an industrial equipment manufacturer which has a global footprint. That means it has multiple plants, some of them in India, some in China and Europe as well. So the idea was to do a solution for one of their problem statements. So the problem statement is in Pune itself, they had one plant, which is age-old plant. Maybe in terms of the industry X terminology, it will be around I 2.5, not even I3. So meaning that there are different systems which are deployed like ERP, there are some point solutions at different departments, and there are Excel based solutions. So this is the status invariably you'll find in many of the companies barring the industry leaders of auto and other dynamic industry electronic component manufacturer. But normally in the mechanical or tier one kind of companies, this is the common statement. So they got sudden rise in the demands and due to offshoring from overseas factories and customers. So they were grappling with their manual operations, right? Since the visibility, the operations, the disconnected functions, all these problems were there. They were not able to plan their production to utilize the full capacity that they have invested in the facilities, and they were not able to scale it further to handle those demands. So to say, though they have built the capacity to handle up to, let's say, 100%, they were able to utilize only up to 70% because of the disconnectivity or the manual functioning paper based operations and a lot of rework, reprocessing, so many things. So this is a brownfield plant which they have been operating upon, and then the management had taken a call to reduce all these bottlenecks, to overcome all these bottlenecks, and they wanted to set up a greenfield plant because they wanted to scale it really fast. So instead of trying to revamp this brownfield facility, they took a wise move to install to commission a greenfield facility in Pune itself, and where they will have all these smart factory solutions implemented from the beginning, right from the scratch, the technology selection, the functionality, the business processes. So everything they reinvented and redefined so that that template or that solution, once is successful, tried out in the green facility, it can be adopted by rolling it out to the brownfield facility. So that was the thought process. And the business drivers for this, obviously the problem statements, significant working capital, that is in terms of the inventory and input cost due to lack of real-time visibility. So in the current factory, they had the inventories piled up everywhere, the work in progress inventories, the buffer inventories, semi-finished products, or even the raw material inventory, because there is no visibility, no tracking, end-to-end tracking of the inventory. So they had to make the buffer stocks available by guessworks or by guesstimates, because to avoid the business discontinuity or business continuity problems. So the cost obviously of this inventory and holding those cost, everything hampered their working capital. Yeah, it not only hampered on the working capital, but the delivery to the customer, default, the delivery in full and on time. So that's one of the critical factors when fulfilling these orders. So that was also being impacted because of all this, because everything had some latencies and delays, right? The third problem was lower FTRR, that is first time right ratio. So when you want to build the products in mass, normally you should be building, or your effort should be towards building the product first time right, rather than doing it on the reprocessing, reworking kind of things. So typically in these conventional atmosphere or manufacturing operations, the assembly takes place through various steps, and then at the end of the line there is a quality testing. So what it does normally is There are some, if there are any defects found, you have to reassemble, disassemble the complete product or the part of it, and they correct the problem and rework, reprocess, and do the testing again. So this is significant efforts, time, and money waste in this process. So that was one of the problems for them. Third, the fourth one was obviously dependent on all this, is the core one, the operational inefficiencies and poor production attainment. So whatever they planned was through their ERP was conveyed on a piece of paper to various departments. Now, when you do the paper-based operations, there is a disconnect, right? Anything which needs to be changed or reprioritized at the ERP end, it takes time to go to the shop floor and to each production center, so that it can be rescheduled, readapted, because there are a lot of things which they need to take care before adapting to this. So connectivity between the shop floor and top floor is very important, so that the impact of any change plan or prioritization of certain orders or holding certain orders back can be really seen in a quick manner, and the response can be given back to the ERP, that what is attainment percentage which is going to be uh, with this kind of change. So that was one of the thing, or principle or a value proposition behind the connected smart factory, where you connect the shop floor with the top floor. And that's what Mr. Mowley said as ITOT, or it is normally referred as ITOT convergence, right? Where the operational technologies meet the IT technology sitting at the top. So absence of digitalization was resulting in poor decision making, prolonged and inconclusive meetings. Now, many of you will resonate with this if you are working in the traditional factories. What you see there is most of the things, the log sheets, the production plan, the work instructions, so many things are paper based. So it's all noted on paper and then circulated at the end of the shift or hourly. They are collected back, someone goes and collects those and keys into the ERP or some other system as a production booking. So all these has a latency, significant latency. So whenever they management team used to meet in the meetings, everybody would run with their piece of paper with reports taken from their version of data. Now the thing is, all these data reports were run at different point of time in the day. So whenever they meet together to analyze some problems or to see some root cause analysis, it was not helping, because the data run by quality was at different point of time, that one run by the production was on different set of production data, while the planning system had a different snapshot of data. So since it was not at the same time frame, it was difficult to correlate and come out to real conclusions, right? So there were a lot of conflicts happening and inconclusive meetings, so a lot of wastage of time there happening. So to ascertain this action ownership and remove this bottlenecks or conflicts, they decided to go for a digitization of all the data, removing all the paperwork. So that was the another driver for the solution. Next one is the fragmented IT. So as I said, the all the departments working on siloed systems. So except the ERP, there were different pockets, the quality, the planning and the scheduling, or the operations, production, warehouse, the supplier management, everything where there were the pointed solutions or the customized solutions, and the integration wasn't there. So it was all on mail or phone or a piece of paper being exchanged. So you can understand that what kind of deficiencies or what kind of latencies it introduces and chaos it creates. So they wanted to remove these fragments and make it a single common platform. And that's where the title connected operation comes in, because the moment you connect the value chain end to end by connecting the systems, your process becomes smooth, right? And at the same time, it becomes agile also. Agile in the sense it will let you see the complete picture, what is happening, and if there is any change, you can easily assess the impact and adapt the change to certain extent. May not be 100%, but 80%, 90% change can be accepted. So that's about the agility. So based on these business drivers, a final goal came up, and that I said is to set up a modern greenfield smart factory which has world-class systems based on the Industry 4 kind of a framework, and all the solutions supporting the operational excellence. So operational excellence remains the core. Do whatever you do, whether it's industry 4 or even the forthcoming revolutions, operational excellence thing may not go, because the word itself says it's a perpetual kind of continuous improvement kind of transformation. Yeah, and then after the success of this solution, it was then targeted to be rolled out in the brownfield plant as a phase 2 of it. So this is a complete summary of today's session with the problem statement, the drivers, and what was the targeted solution. So with this, let's go to referencing the operational excellence 4. Now, operational excellence, you have seen it multiple times, you have heard it, you know it. But with 4.0, it just adds on the capabilities of Industry 4 technologies like IIoT, AI ML, or digital factory twin, which enhances the value further, right? As said, it removes the latency, gives you the connectivity, gives you the real-time visibility to respond to the events in real time. For example, if there is something which is going to happen, and with the AIML kind of thing, if you predict it in advance that this quality curve is going like this and my temperature is increasing like this. So this analysis of these two parameters, this is just a hypothetical example, will give you the prediction that there is a probability of failure of the process or the quality or the machine, right? So with this technology, it is now possible. So we call it as operational excellence 4 feature, where the quality 4 or Q 4.0, that's how we term it. So this is the just for the reference that what operational excellence 4 means and how it combines with the industry 4 to give you an added value and control over your operations, making more importantly, it gives you the power of accurate decisions. So why I'm saying this is because of IIoT and ITOT convergence, you are trying to digitize all the data, right? Instead of paper-based data, now everything coming out in a digital format in forms of dashboards, which you can churn, your analytics engine can churn and come out with different trends or charts or give you different insights. Some of them are predicting also some of the events, as I said. So this fact-based decision making, now it gives you the power of making your decisions on facts, and guesstimate or guesswork is reduced, which probably is there in the conventional things, where you don't get to see lot of historical data of an event, right? In the paper-based systems, you have limited access to maybe a week's data or maybe a 2 days data or some sheets data. And based on that, you have to quickly analyze and give your decision or take a decision for the further processing. So digitization of data gives you that additional or very important power, where the analytics can run on larger set of data. And also it connects different data points. It gives complete contextualization. For example, what is my energy consumption with respect to whatever my power output, whatever my product output, how many of it were rejected, how many of that I have sold. So you can do various combinations, permutation combination, come out with different analytics, right? So you might have seen, most of you probably are fan of cricket. So in the cricket, the entertainment and the sports industries are the first to adopt all the technology revolutions you see. See, over last 7, 8 years, as far as I remember, before we talked about even Industry 4.0, I used to see while watching the matches that there are the predictions coming on the screens. Tendulkar, if survives for first 5 overs and scores this many runs at this rate, there are chances of him making the century are this much, and India winning chances are this much. Now, what was it? It was just based on the data, right? Where they had some software which will analyze all the performance data of the India of Sachin Tendulkar on that ground against that team, all those permutation combinations, and with this, it used to come out with the probability, right? And most of the times it worked and it happened in the same way, right? So this is the thing which we have to apply it in the industry. If it works externally in your social life, in your entertainment industry, so why not adopt it in the manufacturing industry? So that's what is the principle. So talking about these specific targets, now making it more practical, there are different targets for around quality, efficiency, speed increment, and reducing the cost. These are typically high level targets of the operational excellence. But talking about this specific case, they wanted to improve the performance. As I said, the utilization, the output of every person, every machine, right? Throughputs, all those things they wanted to improve. Reduce the inventory level. This was one of their bigger pain point, because they were carrying 72 hours of inventory as a backup for doing one shift of 1 day's production. So that's a 4 times inventory they had to pile up, because of possible quality issues, or maybe delivery lead times of the inventories. So avoid those discontinuation or impact on the business continuity, they had to pile up 72 hours of inventory, which was a huge working capital for them. And with this, we address this problem, which we'll see in the forthcoming slides. Third one was improve the production planning accuracy. Now, once ERP in a traditional or in the conventional process, it will do planning run in the morning, and without considering the factory constraints. Some machine is down, something is maintenance, the worker is not present, or material shortage, or whatever issues. So limited constraints, it used to take infinite kind of planning, and send those paper-based plans to the factories, various departments, and then they had to see within themselves their constraints, and they will do their best possible plan. Again, if you do for one shop, that plan may not go as a same plan for the production shop, right? So this kind of siloed functioning was happening, and there is no one piece flow kind of thing, that this is my target and every department is aligned to meeting that target, that production plan. So that was lacking there, and they wanted to improve this. Reducing rework and reprocessing, of course, as I said. So instead of end of line, they wanted to enable the line operators with instructions or with some guidance, some help, so that he doesn't make the mistake. If he tries to ignorant by ignorance, if he tries to make a mistake, the system would alert him, and it will also guide him not to make a mistake. And finally, still there is a mistake, the system will run a poka or error proofing to prevent that mistake from happening, right? So that's a way of reducing the reprocessing. Sorry for the disturbance. So the next one was the improvement of finished good yard operational efficiency. So they had the finished good, because they were importing, they were exporting their products to various industries, and also there were some domestic customers. So they wanted to segregate this type of compressors based on the import and export markets. Plus, there were some different capacities. Some 5-ton equipment cannot be kept on the higher shelf, it has to be stored as a lower shelf. So all these business rules were there, and they were trying to manage it manually. So that was doing taking a lot of manual efforts in terms of knowing, finding the place to store, and then retrieval of those orders when those SKUs when they wanted to ship, right? So with the barcoding and RFID kind of solutions, we tried to automate this FG yard storage and retrieval function, right, to improve the efficiencies. So that also we'll discuss in the subsequent slides. The next one was enable data-driven intelligence for better decision making. So as I said, basically the meetings were not conclusive, and with this data-driven intelligence, the dashboards, there are certain things or decision capabilities which are enhanced. And lastly, but not least, digitization of data would definitely help in giving you the analytics capabilities, which will probably help you to find out more. Sorry, I'm switching off the video for the better bandwidth. So it sets the foundation for future predictive operations, right? As I said, let me give an example. I have seen a typical car manufacturing or automotive vehicle manufacturing industry. There is a analysis which is done whenever there is a warranty recall, and they want to do the reverse traceability, that what components went into this particular product. There are, if it is a paper based traceability, the number of papers which they will have to refer will if you spread them across a stadium, it will fill the complete sports stadium. Okay, that's how it depends on the complexity of the final product, the luxury and the features also, but it's slightly maybe exaggerated in an Indian context. But that's the mammoth paperwork. Even if it fills the half of the stadium, That's a huge amount of data to be processed on the paper, right? And imagine the kind of time it would take to correlate those data. So if you digitize that, the traceability and other root cause analysis, kappa analysis, everything becomes a matter of minutes or maybe seconds or hours, right? So so creating the data foundation by digitizing, removing the papers out of the system is one of the major or the core part of this industry 4 transformation. It is about the knowledge driven transformation, if I may put it. Okay. So these were the targets or the KPIs which were taken. Now with this, let us go to the solution strategy and approach. So what strategy we had chalked out for devising this solution, and then what was the approach we took for developing, building, and rollout of this solution. So the strategy was to develop a system-driven lean manufacturing processes. So again, the traditional approaches of lean operational excellence, lean is about removing the wastages, right? So it is again a perpetual kind of or everlasting kind of goal. It remains as a part of operational excellence, you can say. So similarly, you have to develop the systems and to try to optimize, minimize the reductions, maybe at quality, maybe the operator moments, improving the takt time, reducing the inventory, all those things, right? So taking out all the wastages. So that was the first principle or a strategic principle that was set aside. There was second one was the paperless solutions for data driven intelligence. So we talked about it in much detail in earlier sections. So going completely paperless. So that is possible only by doing the digitization or from the source of the data. So that could be the device sensors, PLCs, or if it's a system, then ERP to MES or ERP to quality system, those kind of integrations, right? It's a digital integration, not a paper based or a manual integration, which is seen there. The data dump from one system is taken and then fed in or keyed in into the other system by human. So that, removing that thing to make it a complete integrated thing. So creating a configurable solution. Now we talked about the template based approach. So we'll discuss it in detail what is a template approach, but to give you devising a solution with maximum configurability so that it is adapted with very little changes into the other plant or other lines, right? So if you have two identical plants where the business processes are same, maybe you are making products different, or it's a discrete manufacturing, or it's an import based import product line, or domestic product line and export based product line. So regulatory requirements will be different, the quality norms will be different. So some of the pieces of the puzzle or the value chain would differ or the approach would differ, but overall the process remains same. So it's about creating a common template of the processes, the solution, IT solutions around it, the user interface consistency around it. So defining all these things and making it more configurable, that if there are 5 equipments in one line, in one assembly station, assembly conveyor, and in other line there are 10, so we should be able to just configure it as a 5 and 10 and the solution should work. So that was the approach or thought process we carried in designing the solution to make it more flexible. So roll out this solution to the brownfield, right? Once you prove it in the greenfield, there is a production trial for 2 months, 3 months. And after seeing the solution stabilized and it's benefiting, it is to be rolled out to the brownfields. So this 4-point strategy was taken. So we are not doing away with the traditional principles of lean operational excellence, adding the new thing of paperless as an industry 4 strategy, creating configurable solution as part of the agile or as kind of a new development practices, and then rolling it out to the plant. So coming to the approach, once the strategy was there, now the how to go about it. So coming to more ground level, the entire solution approach was based on state of art methodology. So it was again having 5 different stages, as you can see. So first is to do the as is maturity assessment and defining the to be state, right? So this is the very important step in anything you want to improve. You want to define it first, you want to measure, you want to find out the opportunities for improvement, and then take the target state, right? Then define the target state, and then you do the solution architecture for that. So we studied their brownfield plant, which is already there and which was causing the problems. So we studied their processes. We studied the IT solutions, their IT stack. We also took the snapshots of their current reports, right? The key operational excellence targets. What are they? Where they are baseline? Are they doing quality performance of 60% or 70% or 50%? The production throughput efficiencies are 80 or 60 or 90. So all those parameters were captured, and based on that, when it was presented with the leadership of the customer, they took the targets, right? The improvement targets against each of these parameters, which we saw in the earlier slide, right? So that defined their to be state, right? Or the to be maturity stage where they wanted to go with this solution. So when you have the as is thing and you have the to be targets, it makes a job very easy to deploy that kind of solution, right? So when you plan or you define a solution, there are multiple influencing factors apart from cost. There are things, the time to develop, right? There are the complexities to address. There are the ease of use kind of things. There are various linguistic needs. Maybe the China needs the user interface in different forms, India needs in different language, Europe needs in different language. So all these kind of aspects play an important role while you define the solution, right? So doing this as its maturity and defining it to be state, you come to know where to optimize on these parameters to define a solution, right? There has to be a core solution, bare minimum solution, or a minimum viable product is another best practice, where you do the core solutioning, you deploy that, and once the people start using it, they find the value into it, you go on adding or augmenting it with additional functionalities. So just to give you a simple example of MVP, yeah, minimum viable product is, let's say start a sandwich making business. Okay, so initially, I don't know how it will scale, how I will get the customer orders. So sorry, this is not an industrial example, but it's very easy to understand. So I'm giving this reference to understand the concept of MVP. So I'll start with a minimum veg sandwich with two slices of bread, some cheese, and some chutney, and maybe a kakdi and tomato kind of thing, right? That's a basic sandwich. So once the customer tries, and I'll try to offer it at a minimum cost. So once there is a customer who tests it, who likes it, and then I see the demand going up, then I come up with the value adds like extra cheese or putting some broccoli, not broccoli, but the spinach and all those kind of mayonnaise, all those kind of multiple layers. So club sandwich, you may call it. So that's going further up, adding the value. So minimum viable product was just a plain sandwich, and then it goes on to different flavors. The next stage of again excellence there, or again value add there, is you sold the soft drink or hot drink along with that sandwich. So this is how you address the customer's needs or attract the customer to you. So that is one of the approach taken in the industrial solutions or IT solutions also, where you don't go for big bang, try to attempt everything at the, make it simple so that it is easy to deploy, easy to build and deploy, and easy for customer to use it, and they are enlightened or delighted to use it. Once that trust is built, you go on adding the value. So that was the thought process taken with this approach, applying the lean principles by optimizing the workflows, connecting the different processes. Now in this the customer also got a chance to look into their 30-40 years old business processes. There are a lot of manual things which probably muda waste, you can call it, right? The movement waste, the lot of repeated operations, repeated movements of the operator. So they got a chance to optimize those steps, process steps also. So this not only helped from IT side, but there was their internal introspection of the processes, and they optimized their business processes. For that, they had to do some facility alignment or realignment also. The example of this is, with respect to this case study, is the kitting operation. So suppose I am manufacturing product, let's say a compressor. There are a lot of aggregates and some parts which go into making a compressor. Now, besides the standard compressor, there are some customized compressors also. So I do have to have different capacities of compressor. So my kit components will vary. There will be bearing, but it will have different size. There will be some tools or some sensors which may be present in the higher end compressor, which will not be there in the lower end compressor. So based on that, the kit components will vary. So the traditional method, they're all managing it as a Kanban system where all these components of all varieties were lying near each of the assembly stations. So there was a huge inventory locked up, right? You don't know what production plan would be there tomorrow and when to find the right component. So they had a lot of bins around the workstation of the operator assembly station, and he has to choose. And he would definitely make some mistakes if there are so many identical looking parts and there is pressure of the takt time also. So that was a problem. So they redefined this process when we gave them the concept of synchronized production, where once the production plan is finalized, the same thing is electronically conveyed to their supermarket or stores department, whatever you call it, and they'll start preparing the kits. So they design the kit trays for a compressor. What are the components required? So they kitted all those things and pick and form the kits, specific kits based on the production sequence, and then they send those trays or those trolleys on a conveyor to the main assembly line. So it was just in time kind of concept. When the particular compressor comes for assembly on the start of the station, its relevant kit would come and match with that compressor. And then onwards, it will continuously flow with the compressor so that operator don't have to worry about which bin to pick up. Guided with different processes like SOPs or work instructions. So this is one process change. This is one of the process change which they had to do as part of standardization, right? So other than IT systems, they also changed their process. So we together with them defined a common template that these are the key processes which will be commonized across all their plants. Then this is the IT solution stack, that what are the components? Will there be a PLC? What make of PLC will it be? Is there a SCADA? Which make of SCADA it will be? If there is a MES solution, what make of MES solution? How they will integrate? What are the standard interfaces and data points they will exchange? So all these were templatized, standardized, right? Similarly, the user interface, the screens that you build, there were cross plant teams which were formed together, right? They discuss within themselves that what is the best possible user interface or a screen which need to be defined, so that every plant, every station, every line will have consistent looking system, so that operator is not confused while working on different stations or different lines or different plants, right? So standardization of process, standardization of IT solutions, standardization of user interfaces, and defining the key parameters or KPIs, right, for each of the line, each of the machine, each of the plants. So that gives a complete consistent governance platform, right? Once you have everything standardized, it's very easy for you to pull the scorecards, OE of each of the line, each of the machine, and compare, and then find out the root cause why this is performing at lower level than the other plant or other line. And then also make the award the best team, best plant, and then try others to learn from the best plant, right? This creates a peer kind of competition to excel, and reward, risk and reward kind of a mechanism, right? Use of I4 reference framework. So digitization for actionable intelligence, again going paperless, collecting all the possible data was part of it. Then defining the target state architecture. As I said, there were a lot of applications, some of them Excel based, some of them are old technology platforms which were difficult to support. If anything breaks down, it was very difficult for them to fix that. Those kind of things we identified. All the risks in the IT landscape, that is the scalability risk, some of them reaching the limit, like let's say they were running on some Excel based sheet. So it cannot accumulate a lot of data, right? It has limitations. It cannot do a lot of data churning based on its machine's capabilities also. So these bottlenecks, the risks of obsolescence, some technology, let's say running on the basic Fortran, Pascal kind of, so those were identified. There was a proper due diligence exercise which was taken care. And after plotting all this on a piece of paper or a set of papers, then it was not paper, I would say slides, and it was presented to management that these are the areas where you need to improve. So then a proper business case was also there to support these opportunities of improvement, and those formed the digital projects, right? So these were the small chunks, let's say for PLC related things or the machine connectivity related things. What are the different solutions which we need to deploy so that this machine comes on the internet, or this machine starts giving the data. So there could be putting some intermediate hardware for protocol conversion. There could be some logical changes in the controllers to throw that data up to the upper layer of SCADA, or maybe through OPC to MES. So all this blueprinting exercise was done, and target state architecture. This TSA means target state architecture. So this is how your IT landscape will now look. So it was really lean and thin, where all these pointed solutions were taken off the Excel based, or some data Visual C plus solutions, something proprietary solutions. So instead of having all these things, there was a common single monolithic solution, we may call it as a MES, that is manufacturing execution system, which has a capability to address all your functional needs of production, quality, maintenance, inventory, and there are some add-on modules to handle the warranty management, utilities management. So instead of going into siloed solutions of different technologies, different platforms, one integrated solution strategy of MES was given. So we'll see that also in the next slides. So this is what about defining different layers of your IT stack, right? That's ISA 95. You may be familiar how data flows from shop to top through different layers, and what are the technologies at each of the layers. So that is what was defined as a part of the target state architecture, and that was audited, or that was what do you say, questioned, evaluated by different experts from IT, right? They have to see whether this architecture is secure, is there any chances of data leakage or hacking. Also all these 360-degree evaluation was done before finalizing the target state architecture, right? That's one of the key approach step. And then the implementation approach, design and implementation approach of template based solution. So aligning to the strategy, adapting the industry 4 principles and traditional lean and operational excellence principles, these were the high level steps which were defined, and the solution was blueprinted, right? I hope you are if you have any questions, you're noting them down and putting in the chat box as necessary.
Yeah,
Now,
just a point, Hemant, that now I just want you to go down to the time management also, because from 12:45 we have to give some time for Q&A.
correct, sure.
Thank you.
So
Just
yeah. So there is one just question from my side to understand if there is any Industry 4 initiative which is ongoing in your company, or if anything like that is planned in your company, you can just maybe put it in the chat box, so that if you need any help, we are there to solve your problems. Okay. So let's see the smart factory reference framework. So this is a smart factory or a future business model, right? Future factory model, I call it. So if you see on the left, it's a smart factory which is operational excellence based, right? That has to be a key to it, driving factor behind it. It's a demand driven. Now, traditional factories are made to stock, where you just produce based on the material you have and try to sell it in the market. So demand driven is the other way, where it is producing whatever is required in the market by the customer, right? So you don't make the wasteful production of the products, because sometimes you make it and there is no sale, so that's a waste. So to reduce the inventory and other costs, so demand driven approach. So it may not be 100%, but some component of demand driven which you can go over a period to mature it. So that is another key factor of the smart factory, and it's a knowledge enabled, as I said, all digitization and then fact based decision making. So all this is possible by adapting different processes, right? The lean process, industry 4 principles, and the technologies you see in the greener circle. Those are the social media or IoT or AI, whatever options or whatever things are there. So this is the layer which are the technologies, and some more technologies. And at the end, this is completely secure from all the angles. That is, it's data security. That data is not going out of your hands. There is a network security, that your network is not being hacked by somebody else. There is infrastructure security, that your infrastructure, the servers, whatever systems are hack proof, virus proof, and not failing. Also, they are resilient. And then application level security, that right people with right access credentials can only access certain things. So these are the principles behind that. So this is the smart factory model, reference model I had. And the features of it is, of course, first is the manufacture products intelligently, that is the right time, right decision. That's possible only with the data, right? Digitization of data. Do more with less. It's part of optimization. So inventory optimization, quality, rework optimization, process optimization, movement optimization. Work with first time right principle. As I said, let's see that product is made right in the first go itself rather than reworking. Be adaptive. So the change management or changes, your operation should be able to handle certain level of changes. So that's agility of operations. Resilient supply chains. So supply chain, if there is a natural calamity or certain unforeseen situations which will impact your incoming or outgoing supply chains, then you should have a strategy to as a plan B, right? How to best mitigate the risk. Be compliant. So create the records of the systems, the product genealogy or the audit trails or test certificates, everything you do in the form of digitization, so that anytime any regulation audit is there, you are compliant to it, right? Then better working conditions for the sustainability and for the operators. Now traditionally this goal is not much important, but with the digital transformation or industry 4, this has taken a forefront, because worker is your real assets, and giving them the right working conditions, and also being environment friendly to reduce the carbon footprint. So paperless is one of the carbon footprint reduction of aspect, right? And last one, which is the very idealistic view of a factory which operates on its own with minimum set of operators. Now, there are some cases which are there with Siemens and some other teams, that such factories do exist. Those are also called as black operations, because you don't know what is happening, but the things are going in and the products are coming out, right? With dark factories also they are called, because there are no workers, no electricity consumption for lighting, so they are named as dark factories as well. But that's a very distant or end goal where you go as a part of smart factory. So this is the framework which was referenced, and out of this, the goal number 1, that is right time right decision, do more with less, work first time right, and be compliant, create the records. These were the primary targets for it, and of course the agile operations was a secondary goal, right? The principles. So the industry 4 principles on which the whole solution was framed. First is the digitization and digitalization. The difference between these two, digitization is about data digitization. From paper you move on to electronic data. That's digitization. Digitalization is automation of a process. If you are doing something manually, you do it with the automation, right? Or create the workflows where you just see that workflow process from one person to next level, and they do it approval on the computer or on the mobile. So those are the agility principles, digitalization. Then integration and collaboration. So you integrate not only the systems, but through that you create a collaboration between the different departments, right? So that they work as a unit orchestration. Data democratization. What does it mean is, as a part of digitization, you acquire a lot of data, but just acquiring data is not enough. You have to give that access of the data to the right set of people. So for example, if there is something design department which is designing a product, and there is some refresh or some kind of design change or process step change which they are doing, if the production team knows it in advance that this is what is going to be there, so they can prepare well with that kind of setups or tool preparations or maybe material requirement in advance, right? It may happen or it may not happen, but they are at least knowing that something is going to come, and they can monitor, close watch, and that's how they can be proactively prepared. So data democratization means wherever the value can be created of downstream data, it needs to be shared upstream, or vice versa. Then real-time visualization. This is also an important part. As I said, if you want to control something, you need to visualize, you need to see it, right? And that's in real time. Then only it gives you better capability to control. So automation, the process automation. This is physical process automation. Then there is a actionable intelligence. So out of all this data and things, integrations, you create the dashboards which will help you to mitigate the risk, to prepare well for all your future scenarios, or to respond to any event happening. So these were the principles. Now the solution construct and reference architectures. Now this is a part. So still half an hour left, so I should be okay with this. So let's see the solution construct. So the main components were design of a smart factory MES solutions. The core of this was a MES solution, because it is the powerful tool which gives you control on all your production quality, maintenance, inventory, and other operations which we saw or which we discussed earlier. So MES was a core, And it's not the MES as a standalone solution, but when you deploy it in integration with other systems, it's called the manufacturing operations management, which gives the capability of cutting across different systems, different departments, different people, and then conduct the processes, carry on the processes end to end, right? So that is manufacturing operations management. Now MES is only for the manufacturing floor. It takes care of only these four pillars which I said, but when you connect it upwards to your design department or to the ERP department, it gives you the lot of flexibility or lot of collaborative platform. We'll see in the subsequent slides how it. So in this case, it was integration with ERP for production planning accuracy. Then there were third party logistics teams which were collecting the aggregate parts or some raw material parts from the different vendors and trying to send them in sequence or just in time basis to the plant, right? So has to have the reduced inventory at the plant. And then design content server. So this is about the digital work instructions or SOP, which are the paper which flows for the operators to carry out the operations as a guidelines, right? So we digitize that. So digital work instructions is something where the digital models of the product or assembly operations, etc., is being relayed on those machines, so that as part of operator guidance. So these were the first three parts of the connected factory where you do three-way integration. That is your planning system, your logistics systems or vendor side of it, and the design part of it. So and fourth angle is MES. So all your four corners are now as a golden quadrilateral by Narendra Modi ji. So digitalization to make system a single source of truth. So we saw that the meetings were not conclusive, the root cause analysis were not proper. So there was a single solution which will hold all the data together so that all analytics run manufacturing analytics and you get the consistent picture across department. Improved visibility on production floors. So as I said, there were some digital dashboards, reports, and there are some shop floor add-ons also deployed to make the operators aware of their performance, right? It's a real-time update of what is the target and how much they have achieved, how much time to go, what is their productivity, so what are their alerts at various stations. So it acts as a multiple utility for multiple people, right? Even for maintenance people, for operator to raise the calls for help calls or material issue related calls, material shortage calls. So he will have to just press a button and it will be highlighted, also electronically recorded in the system, so that the maintenance turnaround times, etc., can be tracked if you record all these calls and their closure times and the actions taken. So this was about the end-ons. Provisioning of to track work order. Now customer related work orders, everything wanted to be tracked. What is the status of my order? Because if the total turnaround time is, let's say, 1 week for making one product, the customer is you can say in the dark. He doesn't know what is the status of my work order. So if they ask you, you should be able to answer them quickly that this is the status and this is the likely date of delivery. That is only possible if you track the status of the orders in real time. So for that, we deployed barcode based solutions. So each order or each machine was barcoded with a unique identifier, and every station or every line it go in the process, the barcode will be scanned and the operation will be recorded against it, so that at a click of a report you can zoom into particular area and see where is my order, what are the pending operations, what are completed operations. So that was the complete status tracking with drill down. Improving quality, process adherence, and production planning. So this was another feature we'll see in the use case section. Record the genealogy. So this customer had a need of generating the test certificates and sending it with each of the equipment they produce. So earlier they were doing it in the form of paper based 37-point paper checklist they had. So we digitized that, integrated with MES, and based on the type of model which is being tested on the test bench, the MES system will guide these are the standard set points, or these are the standard measures for this quality to pass or to fail. So this took out that human factor out of it, the guesswork factor out of it, and it gives a consistent quality, right? Or the test certificates were also more authentic, more genuine. So e-test certification, barcode based warehouse management, as I said. So at the end of the production and testing, once the SKU is ready, it will be printed with a barcode. Once you scan that, there is a warehouse management model in our system module which will apply the business rules. If this is an export order, which is the area it has to store, then it will check in that area which slot is free, and accordingly it will pop up on the operator station that this is the area you go and stare. You store this compressor. It was very easy for him. Even for dispatching, when there is a pick list generated, he has to just key in the pick list, and the system will automatically tell him the locations that which order is where. And not only that, it will also give him the optimum route that how he has to go in the warehouse picking these orders. So this was the solution for warehouse management. And one important factor was around the preventive maintenance. So there were a lot of tools like talk tools and some other tools which were done in a traditional preventive maintenance. That's after certain number of hours, periodic maintenance. Basically, they used to calibrate, test the equipment. So what happens is sometimes, especially in the COVID kind of situation where there is no production, but the time ticks on, and the people do the maintenance because it's a periodic maintenance. So instead of that, we wanted it to be more realistic and operation based. How many times this equipment or this tool is used, that was tracked and recorded, and based on certain number of operations, it was sent for calibration or for maintenance, right? So this was the further enhancement of the maintenance part of it. Let's go how we went about it. So this is the lean principle or operational excellence principle of DMIC. You know it. And where industry 4 helps is really to define is a manual part where you identify what needs to be defined, or what needs to be measured and how to define it. Then there is a measure part of it, and there is an analyze part of it. This is where the IT part comes in. The IoT will help you to connect and gather the data, and analytics part will help you improve it or give you the analysis to improve. Then again, decision making improving, and control is a manual factor of it. So now here comes the smart framework of I4. Now smart is about the ability to acquire and apply your knowledge, skills, and earlier lessons learned, right, to solve the problem, right? If you have a problem in hand, if you know the previous history, you know the previous solutions, the knowledge base, and you have some techniques and tools which you have experienced in the past, if you all apply that together, your problem will be solved efficiently. That's what is the definition of smart. So what it needs is the data. Obviously, database decisions are more smarter than the guessworks. Second work is analysis. So having data is not the only solution. You need to have the proper analytics capabilities by connecting different pieces of information, contextualizing it. If I get a temperature, this temperature is 90 degrees. How do I know whether it's good or bad, right? Of course, there will be individual alarms, but still you don't know if it is going to impact your process quality. But if you know that it's a incoming water temperature or it's outgoing gas temperature, then probably you know that, oh, there is danger of some vapors getting locked or steam turbines explosion kind of things. I am just giving hypothetical example again. So this is the analytics or analysis. Then wisdom is again utilizing this knowledge and experience with common sense and insight, as I said. And the skill, finally, you with all this data analysis and wisdom, you come out to a conclusion that this is what I need to do, but you need the skills also to perform that task. So that completes the complete this thing of smartness, what you need. So industry for a framework, if you see on the left, we are saying that data which needs to be democratized, that means it needs to be shared across the value chain as and when necessary to give you the actionable intelligence. So data generated as different sources, the machines or systems needs to be shared, it needs to flow so that you do the right decision that is actionable. And for that, what you need is there are operational technologies or machines on your shop floor which needs to be connected to the top floor, that's IT. Because OT is best doing their physical job, while IT is best in taking that data and analyzing it, right? So unless these two combine, you don't get data to actionable intelligence. So this is the basic framework or principle of Industry 4. Now again, uh, there is a question to break the monotony. Do you have a well-defined, scalable, and integrated IT application architecture? We discussed about TSA, right? Target date architecture. If you have any issues in your existing IT systems or targets, especially, you can just put it in chat box, right? So that as a pointer to for our next discussions, one to one or whatever, right? reference, talking about the reference architecture. So this is was the first connected factory or smart factory reference architecture which we used, and it's nothing about but a digital factory platform or IoT platform, right? If you see here a cloud, so it's a complete aggregation platform where at the bottom, if you see, there are multiple devices, PLCs, device sensors, smart meters, temperature humidity sensor, robots, AGVs. So data from all these is gathered through different gateways, converters on different protocols, Modbus, Ethernet, through these gateways and passed on to a common layer of SCADA. So in this case, there was OPC and SCADA already in place. So we utilized that OPC protocol to get this organic kind of communication going in. But there were some legacy protocols also which we had to hard code because there were some machines which were old, right? So we had to define the legacy protocols for those machines. There were custom integrations like ERP system, which they use was a very old ERP system. And in those days, it was not designed to integrate very easily with the other things. However, it was doing best as far as its job is concerned. So they didn't want to go and replace the ERP because it was a global impact. So we designed some custom integrations with that ERP system. And of course, there are some key parameters in the test bench, like the IoT sensors, which we deployed there to get the data over MQTT. So through these different communication channels, the data came to a central platform, a SCADA. Now, SCADA is good for your real-time monitoring and taking decisions around it, alarms and alerts and all those. But there are also data generated in the manufacturing execution system, the product definition systems, or the PLM systems and ERP systems. So this cloud platform, it was not on cloud actually, but it was on an enterprise level data center because they had some apprehensions going in the cloud. So that's another aspect of it, but ideally it has to be on the cloud to reduce different cost of your IT. So all these data and integrations you see here, which will elaborate in the next slide. So all these integrated data points come to this platform. Now, once the data is in the central data lake, what that is what it is called, you can run various analytics and get the intelligence like management dashboards. Then there are some predictive alerts also. There are remote control interfaces given so that if you are not on site, a cyber physical factory is one where you need not be present at the site to give the decision or to control the machine, right? You can do it while traveling also through your mobile or through your VPN connectivity sitting at home. And that's what you have been doing in the COVID part where work from home was as a goal or was a motto. Now, this is an important slide of connected factory. Apart from that data gathering IoT platform or a digital factory platform, this is a connectivity at the process layers or systems layer. So if you see, there is this bottom layer of shop floor where you have your equipment, processes and devices and automation systems also in place, right? And we put this block here as a MES. So MES was mainly to drive the optimized production, enforce the various compliances because it's not left to operator to do anything. It will keep a monitoring whether the operation is right or not, do the POCI okay. Then produce as design means there were work instructions which are coming from the design system. There were some bill of materials, bill of process, that these are the steps which need to be taken for doing particular operations. So those were defined in this. So you see content server, from here the design data, the bill of material, standard operating process, digital work instruction, and some of the specs would flow in MES on standard basis. A particular equipment comes to a station, a barcode is read. Based on that information, the MES system knows what kind of product it is. It will pull that particular bill of material, that these are the components which need to go into the system. Then it will prompt it on the operator screens, and operator knows that these are the components I have to use in these quantities. Then there are SOPs, that is the standard operating processor. There are bill of process where how these operations are to be fitted, which component needs to go in first and which needs to go in later, how what is the torque I have to run. So all these things in the form of SOP and DWI were shown on the operator screen, right? And finally, once that is done, the MES system will capture that data from the shop floor equipment, the torque runner and PLCs, and that thing will go as built informations to the content server. So it may capture, there are variations. If the set point is around, say, let's say 70 Newton meter torque, but it is applied 68 or maybe even 72. So that will be captured and it will sent as a record of genealogy, right? or traceability. And there were some defects also. If there are any defects, those also go into the design department. So those defects probably need root cause analysis or kappa analysis at the design department end, and they may do some modifications. For example, if two pieces of part are not matching and their holes are not in alignment, so or there is a gap, some fixing or some washers need to be put, and then the nut runner is applied. So those kind of defects are captured by the operator, and those are flowing back to the design from MES. So they need to add the process steps, or they need to add the quality plans, or change the design itself. So that's the idea of closed looping this PLM system with MES, right? Similarly, from ERP, on the right side, there is ERP, which will do the production planning and send it to the MES system. MES system will check on various constraints on the shop floor or in the work centers, and then communicate back that this is not a realizable plan, or I can meet it only 80%, 70%. Then ERP will make more optimizations to see that it is as an acceptable level, right? So that plan will flow, the actual capacity and availability information will also flow to the MES in terms of material availability. And when the operations are completed, the as produced, so there is a plan and there is actual production. So this plan attainment loop is here, and it is given back to the ERP. So it is a production performance data, production booking, material backflush, everything goes from MES to ERP. So this is another important loop, right? That's a second loop. And at the bottom, you see the basis 3A and 3B. So 3A is basically the loop where MES system sends the master data, the routing information, if it is a chemical plant or batching plant, recipe information, or some tool set points, digital work instruction. All this information is taken from content server, and through MES, single source of MES, it goes to the machines, because MES knows which operator is working on what job order. So based on that, it can send the correct information. Sometimes it directly interact with the tool and go and set the tool itself, so that operator step is saved in setting the torques and all those things, right? And as and when the information or task is accomplished, the actual parameters go back to MES. Test plan is given by MES for the quality, and the defects are recorded back. Similarly, material stock availability is flushed in, and the consumption is given back. There is a production maintenance plan, and what is the actual maintenance activities carried out. So these are the PQIM different loops which are given, and they typically time booking, scrap, downtime booking, energy consumption, safety incidences, all this information from your shop floor goes back to MES. So MES plays a very key role as an integral role in orchestrating all these functions. Now with this diagram, you'll know that how the shop is connected to top and how they synchronize as a connected factory, a smart factory, enabling the right decision making, right? And removing all the bottlenecks or maybe latencies, and creating the consistent version of operations, aligned operations. That's the crux of the connected smart factory. So this is the reference architecture. And finally, this was the actual architecture, is a block diagram. So there were PLCs, nut runners, barcode systems, end-on systems, and there were end-of-line test benches, as I said. So different converters were put in, and through OPC layer, the data was going to the smart factory MES database. As you see here, there was some SCADA for line control, and there were test system, that is National Instrument LabVIEW system. So all this data, if you see, this is the architecture what was deployed, and there was a content server, of sort of PLM, you can say, where the bill of process, bill of material come, and there is the ERP. So this is how the final target state architecture was defined. Of course, there is a detailed blueprinting, but which I cannot share due to confidentiality reasons. So I just show you the building blocks, that how connected operations can be done, right? Next question is there any formal MES being used in your company? If you are using any pointed solutions, or if you see any chance of using MES, or even if you have MES but you are struggling to make full use of it, you just can write in the chat box, right? Your against your name or your problem and what MES you are using. So with this, let's see the next section. The time left is till 5 minutes. So this is the MES strategy. Basically, I was talking about, this was the crux of this connected factory. And for the MES, if you see on the left, there is a real-time visibility. So into all your operations, inventories, anomalies, whatever happens on the shop floor, in the machines, in the sales, all will go through the connected factory onto the real-time dashboards, and it will be reflected on different people. So operations supervisor will get a different dashboard, maintenance people will get a different dashboard, materials teams or stores teams will get the different kind of dashboards. So all this is possible using this MES. That's the first option. And again, it will log the data also for future analytics. The second module was around order management, where you barcode a particular order based on the features, characteristics, right? And then that is used for tracking the work order at different stages in the production. And then WIP tracking, that is where this semi-finished work orders, as they move progress across your shop floor, they go on consuming certain inventory, or some parts are getting married to the main part. So that is also tracked as a form of real-time thing, right? Which work order has consumed what part. So at that level of barcoding was done. Then there is a maintenance management, usage tracking and calibration. So we discussed about the tool tracking, right? So usage of the tools based on their barcode usage, the MES system will capture that this tool was used for this many number of times, and it will generate the maintenance plan for the maintenance teams. There is a performance management. So all these OEE, downtime, failures, quality, rework, defects, all these things were captured. The energy consumption, everything was captured through this model. And the manufacturing intelligence KPI, if you see here, different kind of parameters were derived. Even the warehouse related pick and place times were monitored, right? So each department's key KPIs performance were tracked. The third one was traceability and genealogy. In the whole process of making the production, you need to capture the material consumed, the lot size, the batch size, the vendor who has supplied it, maybe the process parameters, the talk tool parameters, and what parts went into it. So it's a genealogy and traceability. So you can trace back in the event of warranty recall or rejection to a minimum quarantine size, right? To reduce your warranty related things, and also run the kappa to improve it further. And for dispatch management, Kanban system, right, for material management. So as part of the kitting, as part of third party logistics, which I explained. So this was the another module also with the warehouse management. So these were the 7 key modules which were deployed as a part of this MES solution. Let's go to next section. So before that, do you think the MES potential has been fully leveraged? So this question I asked you earlier. If you have MES or some sort of production management solution, but it's not being leveraged fully, or there are some scope of increasing the utilization, you can probably write it there, right? And do you feel if you have any industry 4 initiative going somewhere, but it's stuck because of some reasons, you can also ask for help by writing in the chat box, right? So last slide probably for today is implementation best practice, which we discussed. So so this is the template based approach, right? On the left side, since this solution was to be deployed for 2 factories initially, and there was a future scope that if it is successful in the India factories, they would extend it to China and to their European factories. It was monitored from their European team, right? The IT team sits in Europe, so they were monitoring these projects, though this was owned and driven by India for their specific needs. That's why we thought of making the world-class solutions or best practices. So there is a core template where, as I said, standardization of processes, functions, IT stack, all were defined a consistent version here in the template, and then some modules were built on this particular thing. But these will remain when we deploy the solution to all the factories. So it covers almost around 60-70% based on your product similarity, operations and asset similarity. 50 to 70% common code can be deployed in different factories just with a configuration. Then there were some functionalities which are basically little variation. Like I said, regulatory compliances may be different in India, may be different in Europe, right? So those variations or those kind of workflow variations will be as a part of the second layer. And the third one is site specific. If it's China, they need a different kind of linguistic dashboards. If there is a different kind of PLC which is being used, or which different kind of integrations, components or controllers are used, then you need those site specific configurations. So the whole development was in this 3 approach, right? First was a core layer, which was consistent, then was this, and then was this. So if you see here, 60 to 70% code is transportable, interoperable, changeable, right, with configuration. Some portion, 25-30% localization, that gives you this complete kind of solution. So if you see this orangish or amber part, It's about the global UI, user interface, a consistent definition of interface, look and feel. This gives you savings on the operator training. Whenever new operator joins, or there is a transfer from one plant to other plant, you don't have to retrain the operator because all systems are same, right? Look and feel are same, except the language maybe. The process, operating processes are also same. So this is how the standard world-class factories operate. So processes are same. So again, there is no training required. Global roles configuration. There are standard roles which are configured, the operators, supervisors, and then auditors and quality inspectors and so many other things. So all those role definition can be common. The master data also can be a part of the core template where you once define that this is the data which this machine or this system will have and which will be exchanged. KPI part of it, the governance part of it can also be common across all the factories, right? Then global system architecture. So these things are the part of global template, which is common. And there, as I said, L2 integration, country specific regulatory needs or customer specific needs can be a variable component. So this is the approach of designing. This is how we designed and deployed the solution as well. Now, there are some use cases, but I think we already discussed as a part of the MES explanation. So these are the functionalities again. The scheduling, sequencing of release shop orders. Ms. Molly, if it's okay, I can extend maybe by 10 minutes because we said 1+ hours, right? Hello.
Hemant, yeah, the point is that there are a lot of questions that come on the text box.
Oh, okay.
And our program ends at 1. We can stretch it to 1:15.
Okay.
But beyond that, it may not be appropriate.
Okay. Thank you very much. So these are the modules. So I'll not read into that, but some of the things are like pick to light systems. We put there. Digital work instructions was one thing we put there. We also had IoT based energy monitoring system. We had the SMS alert system. So these are some new things as a part of digitization which were adopted, right? So this is the final architecture. This is how you see the blueprint of that connected operations. This is again at a high level. At the top, you see a ERP system, which is their proprietary kind of or maybe legacy kind of ERP system. There is a work instruction SOP server or a PLM server, you can say. At the bottom, there is a production. Now, production consists of assembly operations and testing operations. On the left, you see the materials operation, that is the logistic operation. Third-party vendor warehouse, then internal supermarket area for kitting and supply triggers, and there is a connectivity as a kit supply trigger, and the supply will be in the basis of JIT and JS, right, to reduce the inventory. So this is the integration of production with your third party plus logistics operations. So this is one connectivity. This PLM, that is design part, connected with the assembly, so it will prompt you with the right work instructions. That's another connected operations between design and production. At the ERP level, the bill of material and the production plan are given back to the production, and production will in turn give the production data and the quality alerts, other stuff back to ERP, right? So that's another integration. Now within assembly and testing also there is integration, that assembly has finished these parts and testing can test benches can be scheduled to test those parts, right? So if there is one particular type of test parameters which are set, a test plan is set on the machine, and there are different 5 different or 10 different finished products are lined up in the testing, it will resequence. The system will suggest which one to go next, because similar compressors probably need to be tested in one go so that you reduce the setup time. So this is another saving, right, because of this connectivity. And then the test certificate generation. Coming to the warehouse part, once testing is over, product is found okay, a barcode is printed, and there are business rules of these operations, as I said, where to store what. So based on those rules, the operator is notified for the location where what needs to be stored. Similarly for the pick list part of it, what needs to be dispatched and where it needs to be picked up. So this is how the entire connectivity of all the functions, right, end to end value chain connectivity, from vendor to top systems of planning to production to shop floor to finished good warehouse, right? So this is the smart factory feature. Now the use cases are you may be very familiar. I'll just explain in a minute. This is an and-on tool. This was a very basic discipline because they had paper-based things or call-based things. The operator, if in trouble, he would try to call the maintenance person or a supervisor, and it will waste a lot of time, and his operation may be delayed. So we deployed a and-on based system with a with a simple push button kind of thing where he presses it, whether it's a production issue, quality issue. Based on that, the line controller will take action on whether to stop line or to alert, and there is an end-on dashboard which you see, which will raise an alarm, which will log that, and the maintenance operator will pick up the call, corrective action will be taken, and he'll close the call. So you get the entire maintenance cycles or material cycles data here, and you can do the various kind of analytics on this data. Second one is around the error proofing or first time right. So it's a three-stage approach. It's important, so I'll just explain. So first, as I said, is to guide the operator for doing the things rightly, right? Through various digital work instructions, right? So operator on the display will get a work instruction what needs to be done, because he'll scan the barcode, the job ID will go to the MES will show him the digital work instruction, standard operation instruction. If operator does it, the MES system will sense whether the tool feedback is correct or not. If not, it will give him alert that this is not right. It will not let the job move ahead. So that's the basic guidance thing. Next thing is alerts and warnings. So we introduced pick to light, where there were bins and lights and buttons around it. So as and when the again job ID is scanned, operator is prompted with the lights on the pick to light system that these are the parts and this is the quantity he has to pick up. And there are infra sensors in the pick to bin light. Once he picks the parts, it will be sensed, and accordingly, if all parts are picked up rightly, the MES system will create a go ahead based on the operation completion. And third one is a POCAIK, that's the prevention. Suppose there is a job ID again, the MES system gives him the set point, and operator does the operation. If there is some issue with the tool or with the operator, the tool OK is not generated, system will not let the job move ahead. So there is a reduced quality errors propagation downstream, and end of line quality will be less burden because we are containing the quality at the station only. So this is a three-way method. This is the serialization and those things which we discussed. So I think this last slide is about the savings. Now you may be interested with all these things, what we could save. So the biggest saving was in terms of reducing the work inventory levels, right? So as I said earlier, they were holding 72 hours. That's almost 3 days inventory in advance for doing 1 day production. So it is now reduced with JIT, JIS and connected factory to 4 hours. Now they carry only 4 hours inventory because their warehouses are well connected. They get the information in time, they can supply in time. So lead time is minimized, and that's how the inventory levels are reduced. The production realization, the production attainment is also 30% improved by 30%, because now there is a better connectivity and sync between ERP and MES. Productivity of the people, machines overall increased by 15% maximum, depending on different levels of sales and machines. Semi-finished good is another thing where semi-finished products were lying in different buffers. So that is a major reduction as a part of this inventory also by 20%. First time right rate improved by 8 to 14% in different department, different products. And reduced meeting time is another big saving, because earlier meetings had a lot of conflicts and those things. So with this consistent dashboards, they reduced it. Now that's the last question. If you're confused, if you are willing to do MEAs or Industry 4, but you're confused on how to start, where to prioritize, probably you can put those things in the chat box so that we get the information, probably can collaborate with you or help you. Now, these are some sample dashboards. I will not go into this, and just go to the Q&A session. Thanks, Mr. Moli, for allowing me 5-10 minutes over. Thank you. I open it for Q&A now.
A fantastic, very comprehensive presentation. Hemant, thank you very much for doing it for the Chamber of Commerce members. And maybe you can come back to the video and share the file. There are many questions that come in the text box. I think Hemant, you can also read. I can also read. Yeah.
Let me see.
This sequence, it doesn't matter. And you can go backward, you can go forward. Many have come.
Yeah.
So maybe you can unshare and come to the video.
Yeah, I'm doing that. So there is first question. What I see is from Ramnath DN, right?
Not a
Chan-
question. You can skip.
okay, sorry, that's not a question. Bhushan Badal. Okay, these are just the names, right? Okay, so actual question.
Background. There.
Sorry.
Ending the
Huh.
assignment.
So I think this is the first question probably I saw. How do we do this if customer cannot go or do a greenfield approach? So there are different methodologies. This is a question I am sure it will come as, because this was a typical greenfield thing. But as I said, the approach remains same, where you do the as is exercises, you define which are the areas which needs improvement. So that methodology of as is study, right? So you define that, or we help you define that, and prepare a roadmap for you, that which are the sections which you want to prioritize, probably based on the business cases also. We'll study your data, we'll study your systems, we'll find the areas of improvement and connect it with your existing data, your reports. And based on that, we can say that with this solution, you can take this target to improve a particular thing, maybe quality or productivity, all those things. So that's how it is doable even in the brownfield thing. And we are doing it for a lot of customers.
What is saying, in other words, the approach is whether it is greenfield or brownfield, it is almost similar, right?
Right, right,
Hardly makes any distinction.
correct.
Except that my experience, Hemant, has been that in a greenfield, you have a chance to do an end-to-end solutioning, which is more comprehensive and not challenged by the bottlenecks of the brownfield.
Right,
Bottlenecks of the brownfield primarily is people related. That is a change management issue. The challenges of why should we do it is too much discussed in the brownfield, because whatever we're doing already is good enough. Is a kind of mindset issue in brownfield. There are some rigidities on the technology front, infrastructure front, but people front issues on brownfield are more challenging than the greenfield, because by definition in greenfield there are no people except
right.
probably the managing director and the project manager. Okay, so other questions?
Absolutely right, sir. This is a good point, that change management and rigidity of the systems, which I spoke about, but change management is also
Correct.
an important part, right?
Correct. So other issues are coming as, will supply chain bring changes in smart based organization if all the methods are adopted? Looks like a generic question.
Hmm.
Maybe Ms. Advika can explain it better if she's still on the call. Hello, anybody? Some audio was on. Advika is asking, will supply chain bring changes in smart based org? It's a very generic question. I'm not able to understand that. If Advika is not there, we'll skip it. Mr. Ravi Gaudra, I think is only his background. What is a typical time frame for the transformation?
Yes. So for this
Mr.
particular,
Subramanian,
yeah, sorry, for this particular implementation, which was consisting of 15 different product varieties across 2 plants with 8 different lines, product lines, right? So these are the parameters which dictate the timeline, right? So based on that, for greenfield, it took us around 10 months with 6 resources, which included the controls, PLCs, and IT resources. So it took around a timeline of 10 months for us, because it's the timeline started from the commissioned plant, right? Because the system commissioning or basic facility commissioning was not part of our scope, so it was there. Once that was done, everything up and right, we started deploying and integrating the solutions. But the parallel development was there, and the final integration and come out with the production trials and SOP was 10 months timeline with 6 resources.
wow. Can you just repeat what are those 6 resources? Very important point to mention.
Yeah, so those involve the definitely the automation related resources, PLCs and SCADA related resources for integrating your shop floor assets. There were some people who are expert on the IT system integration, right? There was a solution architect or system architect who will own and govern that complete smart factory architecture, right? And then there were the database architects to define the data, right, of each of the exchange interfaces, all those things, and then coders. So of course, project management,
Okay.
program management were there,
What
but
you're
these are
saying
the
is most of the resources are related to technology.
correct. There were
Understood.
project and program manager, but I
Understood.
did
Yeah.
not mention
That
that.
is also, integrating for your project, the resources we are talking.
Yes,
So the capacity was related to the number of people deployed in these resources.
Right.
So what is the rough number of people in all the 6 resources put together, regardless of the levels of people?
So it was around between 12 to 15 based on the different
12 to
phases
15
of.
people supporting to do in 10 months time,
Yeah.
a greenfield venture.
Yeah.
And the ticket size of this venture is roughly, if you can give even a slab of crores of investment versus crores of turnover kind of thing, some kind of order of magnitude. Is it a 10 crore turnover company? Is it a 100 crore turnover company? Is it a 1,000 crore turnover company? Just order of magnitude.
So it was somewhere between 500 crores to 1 million. Okay. Based on the different products, but that was the range. I would say 500 crores
Rupees,
kind
yeah.
of company.
Okay, so that is when
It's a MNC basically. Yeah.
when the project is ready, then they could reach a capacity of 500 crore turnover, is what you're saying.
Right, right.
Good. So that gives an indication that
Absolutely.
10 to 12 months, if you have done some concurrent activities while the project is getting commissioned, you said that you are waiting for all the infrastructure to be over. But in some cases, I know one public sector recently gave a tender where even before the greenfield project is ready, yeah, they said, can we start even the digitalization? In fact, digitalization project, they want to finish even before the infrastructure equipments are ordered. So they want to align both. There's a lot of innovative thoughts going on, even in public sector.
Correct.
The same project you are doing to do in a brownfield, what will be the duration time frame?
So duration time frame is dictated by many factors, but
It will be
generally
longer.
it should,
It should be longer.
no, it should be shorter because of the template based approach, right? 60% if the template is common, then it should not take that much time.
No,
So we
suppose
took
there is a company which calls you to do only for brownfield. No greenfield template is available. You
for
just do it for a
brownfield,
brownfield company.
definitely it will be longer. It will be longer, definitely.
At least
Because the
sometimes-
main problem is getting the time to do our work, integrate and test, also finding time for UAT, also finding the business users time and the downtime, right? These are the factors which delays things.
Because people are always busy in the regular production, quote unquote.
Yes.
The Bhushan Bhatt is asking, if we want to learn Industry 4.0, Smart Factory would like to be part of this transformation. Will you please recommend Training Institute program certification? Wow, brilliant question. I think Hemant, you can take over this question, but I can also add to this.
So I think there are many certifications, but it all depends, or it all starts with some smart factory foundation trainings. Now, this seminar of today was guiding you or hinting you towards some of the things, ingredients, right? It's not about everything. It depends on different domains as well, different methodologies also. So I personally am working as a trainer, and I do have smart factory
Oh, you yourself can do training also. Very
training programs as well. Plus Mr. Mauli sir also through his consortium has a lot of programs. So my programs are individualized, not very certification kind of things, because I'm a freelancer. So I work on creating the awareness, giving knowledge, not into more earning business or giving the certification. So that's where probably you can connect with him smallly, and through that we can channelize on these things. So sir, you can add probably.
There are many programs available, regardless of Mauli's consortium is for a different purpose. There are many programs. You can refer to National Skill Development Council, where many of the digital training programs are rolled out. There are 2 or 3 large corporations who are like Tata Consultancy Services, for example, or having many training programs. Tata Indian Institute of Skill is just coming to roll out. These are large corporations. There are many medium-sized companies, and I think Department of Heavy Industry have published a list of technology providers and technical training providers in their website, Department of Heavy Industries, which you can go into Ministry of Heavy Industries, MHA. And recently the directorate, they put that various bodies the training. And I would also add here Samarth Udyog Digital Manufacturing Centers. There are 5 such centers in the country. Indian Institute of Delhi, Indian Institute of Technology Delhi, Indian Institute of Technology Kharagpur, Indian Institute of Science, Central Manufacturing Technology Institution CMTI, and Center for Industry 4.0 by the Kirloskar Group in Pune. So these are all the Department of Heavy Industry funded centers. Another 30 more centers are coming up to train not only the awareness part, then there is a knowledge part and there is the skill part. There are 3 levels of training. and you all can go into this Samarth Udyog, SAMARTH Udyog UD. I don't know time to type it. Maybe I can type it out for people to. This is a very, very important point because in this country, the adaptation is more because of the people awareness and people accessibility. Hello, somebody's audio, I think, is not well also. So I'll just type it here. Samarth Udyog. Type it out, you'll get all those 5 centers coming up. Yeah. And Mahapati sir is asking, how do the companies handling IT issues? Wow. I mean, internet facilities, important factors drive smart factory without any breakdowns. Yeah, and internet speed. Any suggestions or input session learned come out of management internet issues. Okay, sir. I think this is your domain, Hemant.
Yeah, so I think this is problem being faced primarily on the shop floor or the remote areas. So there are various options. Again, they need to be evaluated on the cost because there are dedicated LAN providers or fiber optic network providers, but it has to be evaluated with right business case and it should align with the IT strategy of the organization. The another thing which is coming up is the 5G revolution, which is going to set a mark in itself, and it promises to connect everything in every corner at whatever speed it wants, right? It's all customizable, configurable based on your need. So that's what promise it is carrying, and it will never hit any communication bottlenecks or disconnections, whatever area you work in. So that's a promising thing which will probably give a boost to this digital transformation. So let's wait for that, or till that time the lease networks is the solution.
I'm a little cynical on that point because
Yeah.
even before 3.0 and 4.0 settle down, we hope that 5.0 is solving the problem. Similarly, even before 2G, 3G, and 4G are settling down, we are hoping that 5G will solve the problem. I think the human nature is to always hope for the best and assume the worst.
Yeah.
So that is how I think Hemant is a very optimistic person,
Yes.
like me. So I hope 5G will solve the problem. One of my friends told me, whatever they launch in India, you have to minus 1.5 to that. Because current 4G is equal to 2.5G in the rest of the world in terms of speed and connectivity, etc. It's a big problem. I think the IT person, not only in shop floor, even in offices. Even today morning, my internet collapsed. I have 3 internet broadband devices in my room, but all of them collapsed because everybody are riding piggyback on one major brand, and you know what, which one it is. Well, I think there are no more questions coming, and we have another 5-10 minutes, which is called our spillover time, Hemant. So I would like to ask a question on behalf of the 30 people still on the call. It's a long masterclass. First of all, thank you very much for getting into the great detail. I'm glad you took up a case study because most of the webinars, they start with the theory and after 45 minutes, they talk about a case study. Whereas throughout your presentation, you took the case study as a backbone and then you did a thread of all the things around the case study. So which is a very good approach. I hope I will also guide the other speakers coming up in the next month to think of this methodology. Yeah, it's a beautiful methodology.
Thank you.
And I liked all your illustrations in the second half of the presentation, which normally becomes very valuable. When the pictures are there, we are able to align our thoughts. One question from my side. In your big project with the 500 crore ticket company, did you also take along the vendors? I could see your stores to warehouse final picture. You know, you're talking about a value chain which is within the premises of the manufacturing company. But invariably, you must have taken along with you, both in the greenfield and brownfield. If you have done that, can you illustrate how the vendors are also brought into the digital transformation in this particular case study? Or if it is not so, are there other case studies which you did where you also brought in the vendors in the journey of digital transformation? Thank you, Hemant, for that.
Right, that's a good question, sir, and I think that's a very practical question people would be thinking of. So definitely, when you talk of digital transformation, you have to see the entire value chain, right? That is the crux. So it may not be limited to your enterprise only or to your production chain, but you can connect the vendors, you can connect the customers, and your products also outside, which are moving on the road or maybe in the factories. So here, definitely, yes, the third-party logistic warehouses were operated by contracted parties of the OEM which we work for, And as a part of that strategy, at least for the greenfield, since it was a greenfield operation, and as I said, it was a new concept or new process they were standardized on JIT. So they aligned the third party vendor also. It's a world class based practice. So they wanted to adopt by themselves. So inclination of that were there. The thing the concern came when it's went into the investments, right? Normally people don't want to invest only for you, right? So that's where the concept of amortization and other stuff, somewhere the forward looking organization, they tried to take it as a pilot, right? The three party, there were three 3PL vendors. So one of them took it as a their digital transformation, internal digital transformation. They tried to run it as a pilot. So that was their one good strategy. The other two were quite happy with their current loads and other things, so they did not have the time to
ज्यादा order है, उसके बाद बहुत
yes,
order है.
yes, ये disruption उसको लेना नहीं है.
Complacent with
So
lot of orders. Business is very good.
yes,
Okay.
yes. So we started with A-class high value items only, because that will give us a lot of savings on inventory capital, which was the problem statement of the customer. So A-class products we targeted, and we chose some 2-3 product lines, right? And the 5 sub parts of those product lines, and that's how we started. And once they saw that it reducing their operation cost also and efficiencies are there, they rolled it out or they adapted it.
The second question I have before we close this thing, another 27 people still listening to us, is that while this is an Indian, while it is an MNC located in Pune, whatever learnings were done in this digital transformation at Pune, was it also carried forward to the global footprint, or was it only a proposal?
So it started with that objective, because you know that everything is controlled from Europe or some office outside India, right, for the MNCs. So initially it went through a lot of hurdles, right, to convince, and why India is driving it, why it will be driven centrally, all those things. But then Indian customer here put up a strong case that we are trying to provision it through our budget, and these are our problems, and we take ownership of this. This is how it will solve our problems, and definitely it will help you in global your demand management. And that's how they gave the clearance under the conditions that they will be governing.
Oh, I see. So you had a difficulty in getting the approval from the global corporate
Yes.
office.
Yes.
Wow. So this is a problem I feel.
Yes.
Many of the companies, my friends I talk to in Bangalore, they say, no, it is not approved by Germany. No, it is not approved by Switzerland. No, it is not approved by Japan. No, it is not approved by Sweden. Digital transformation, in my opinion, India can set an example to the rest of the world. Even if there is a cash flow and return on investment problem, I'm sure at least the bottleneck of bureaucratic approvals
Correct.
can be overcome. Therefore, I really appreciate that in your case study, you first got the things cleared for the Indian operation, and with that conviction, my next question, follow-up question is it then extended and translated to at least one other site across the world, or was it only a wishful thinking?
No. So this solution was so beautifully fit in their operations, and it gave them the kind of returns which was obviously governed by their global office or head office, which is in Europe. So they were keeping an eye, and when they saw that it is yielding good results, they definitely the Indian operations owned it, and they no more involved us in selling it internally within their operations, right? So only when it comes to the rollout part of it, they would contact us, and that's their next territory they are targeting is China.
So what you're saying is, okay, let's at least try in Asia, kind of
Yes.
little bit of
Yes, there is some
upper lip kind of
geopolitical issues also, right? Why to get this developed in India and roll it out here? We can do it locally. All that kind of bureaucracies, or as you said.
cross-cultural challenges
Correct.
are also there. Okay,
Correct.
good. No, another day I would call you 3 months later.
Mhm.
Experts like you are very busy. I have to disturb you at least once in 3 months.
It's our
At
pleasure.
that time, you should talk about, in similar or more case studies, what are all the people-related challenges you face at the grassroots level, at the middle level. Middle is always the biggest bottleneck in any company. But all of us have gone through middle. So there's no arrogance in talking about the middle. And then the top level bottlenecks, some cases. And in the case of MNC kind of thing, top, above the top level. So all people related, if you could capture in a kind of, I give you 3 months time to prepare this. It may be a couple of case studies, not one. Because this is the biggest learning for India. in terms of implementation and adaptation of a new project called digital manufacturing. And one last question from my side before we close is very, very important point, Hemant, is when we do all these projects, I don't know, in currently after the pandemic, is there a faster rate of adaptation? I don't know which year, which period of your career you did this big project which you mentioned today. Was it 10 years back, 5 years back? When was it roughly?
This was 5 years back.
5 years. So around the time when Germany was talking about Industry 4.0, 2014 when the Acatech gave the name called Industry 4.0, and then McKinsey hijacked it and so on and so forth. So the point is, if even an European world started it only 5 to 7 years back, if you are done in 5 years back, hats off to you, Hemant. The point is, in the current pandemic thing, is the acceleration is faster or it has slowed down the things?
It's definitely faster for two reasons. As world is changing, people have to change. They have realized, so they are
Is it
trying
due
to
to the
make a move.
pandemic or in spite of the pandemic?
No, both things. That's what I'm saying. The natural progression also contributed to it. A lot of more and more people. The word is getting spread, and they're trying to adopt at least some pilots, some pockets. And pandemic also has helped. It did boost it in remote monitoring, remote operation, digital twin part of it, or the CPS, cyber physical factory part of it. Not complete entire gamut of digital transformation, but I would say it's a contributing factor as well. So just to your comment that you said we started it 5 years back. So that time it wasn't called as IoT or maybe Industry 4, right? This is a newly
what was
coined
the name
terms.
given that time?
It was called as MES or MOM, right?
Achha, achha. It is not
Or
even digital transformation.
connected factory at the most, connected
It is not
operations.
even digital transformation.
No, these are the names which we probably or the customer also adopted later.
Then there is a related question from my side. If the same project, if you are doing for a different company or the same company, let us say next year or this year, what would be the different way you would do it with a humongous Industry 4.0 knowledge you have gained or the world has gained? What will be the different thing you would do at a micro or a macro level? Because that time it was not even called Industry 4.0.
Correct.
Anything different or it's the same thing?
No, technology part or underlying components will change. Like earlier, we used to do wired connectivity, but we are capturing the data, right? With IoT and miniaturization of sensor, probably it goes more deeper to capture more data, right? Instead of earlier, we were monitoring the conveyor health in assembly production, but now with IoT, you can go to motor level or the gear level and try to increase the availability of that.
That's a very good point. So what you're saying is, even 5 to 10 years back, the popularity of using internet enabled, like the Ola and the Swiggy and Zomato, I keep using that same example for a common man. If the internet enabled systems are a new breakthrough, Mr. Hemant Patil would do this whole project again in a different manner, but going more grassroots level sensoring and data capturing to improve. And then I think even the other buzzword of artificial intelligence and machine learning would not have been there 5 years back. So the predictive analytics and proactive analytics is another science. So on the one hand, you are talking about internet enabled technologies, and on the other hand, data analytics based technology, which have overgrown in the last 5-6 years, will be your two major pillars you will deploy. Maybe if the same client calls you again, you might find these opportunities to improve that same company. Thank you very much, Mr. Patil. Any last remarks from your side?
No, I think I would again thank you and BCIC for hosting me or giving me an opportunity to present on this platform. And thanks for the good amount of audience. It's good that it was a weekend, so I think we could get a good audience and some good questions as well. Hopefully, I am able to add value and looking forward probably to discuss more opportunities or more sessions. As you rightly said, that's a very nice topic you gave me. Let me see what best I can do for that as well. So thanks you again. Thank Rupa also for coordinating it.
Thank you, Hemant. In fact, you are the first of its series for 2022. We had a similar kickstart of another series, which are initiated by the college professors last year, of 10 programs coming every Saturday. And that is now almost the 10th one will be over next week, I think. And therefore, it is dovetailing with a new series by industry people like you. And therefore, if industry people also can become professorial And if professors can become industrial oriented, I think what else this country requires. This will be a
Absolutely.
fantastic confluence of academia and industry. Thank you very much, Mr. Patil. Thank you all the audience. I think 50% of the audience remaining after 2.5 hours is a very rare event in Bangalore Chamber of Commerce.
Oh,
Thank you,
that's
Rupa. I think all of us have a good weekend. And thank you, Bangalore Chamber of Industry and Commerce. If people have any more questions, I think many of them have noted down Hemant's email ID, which was almost figuring in every slide. Very innovative concept. And somebody asked my email ID. I put it there. If any of you are not able to reach these emails, you can write to Rupa, who has registered you, and she will forward to either Hemant or me, as the case may be. Thank you very much. Atmanirbhar Bharat. Jai Ho. Thank you very much.
Jai Hind. Thank you. Bye.
Jai Hind.
Thank you very much, sir.